Every proof-of-work coin is the same game underneath. Trillions of machines racing to find one rare number below a difficulty target. Change a nonce, rehash, repeat, until you get lucky. That part never changes. What almost nobody explains is that the function you hash with decides everything else. Who gets to mine, how much energy burns, whether the work is useful at all. So let's trace 5 proof-of-work algorithms, from the dumbest and most bulletproof to the strangest frontier in crypto. Let's trace it. Start with the simplest possible. Bitcoin's SHA-256 run twice. Hash the block header, hash that hash again. Check if the number is small enough. No memory, no tricks, just raw blistering repetition. And that's the superpower. Battle-tested, perfectly predictable, brutally fast in silicon. But simplicity has a price. When a function is this simple, someone builds a chip that does only that, an ASIC, millions of times more efficient than your laptop. This kicked off crypto's longest arms race. zkPoW, then GPUs, then FPGAs, then purpose-built ASICs from a handful of giants like Bitmain. Today, a competitive Bitcoin miner isn't a graphics card, it's a chip foundry, humming in a few industrial farms. Maximum security per watt, but the dream of anyone can mine is gone. So the next generation asked the opposite question. Can you design a hash an ASIC can't beat? Answer 1. Monero's RandomX. But first, the war that led here. For years, Monero played whack-a-mole, hard forking its algorithm every few months just to brick the ASICs that kept appearing on its network. RandomX in 2019 was the truce. Instead of hashing with one fixed function, RandomX generates a small random program from each block, and your machine actually runs it inside a virtual machine. Random integer math, floating point, memory loads from a 2 GB dataset. To mine it efficiently, you basically need a general-purpose CPU, exactly what's already in every laptop on Earth. An ASIC for RandomX would just be reinventing a CPU IA. Pointless. And this matters more for Monero than anyone, because Monero is crypto's flagship privacy coin, fully anonymous by default. A money that hides its users can't afford to hand its blocks to a handful of ASIC farms. So Monero stays CPU mined and stubbornly decentralized. Answer 2. Kaspa's kHeavyHash. Kaspa launched fair. No premin, no insider allocation. It's ghost DAG block DAG running from day one. The tactic: make the hash heavy with real linear algebra. The core step is a matrix multiplication, sandwiched between 2 Keccak hashes, the same family as SHA-3 That matrix work leans on memory bandwidth, narrowing the gap between custom chips and GPUs, and it's light enough to feed Kaspa's DAG, where blocks land every second. Same goal as RandomX, resist specialization. But here's the catch: no anti-ASIC trick lasts forever. By 2023, River and Bitmain shipped Kaspa ASICs and pushed GPUs out. The lesson keeps repeating: anti-ASIC buys time, not immunity. Which is why a third camp stopped asking how to make hashing harder to optimize and started asking something stranger. What if the hash were built to be proven? Modern crypto increasingly wraps work in zero-knowledge proofs, math that lets you prove you ran a computation without revealing it. But classic hashes like SHA-256 are a nightmare inside a proof. All that bit flipping explodes into millions of constraints. So researchers built hashes from the ground up for this world. Poseidon-2 is the leading one, an arithmetization-friendly hash. Instead of flipping bits, it does algebra over a giant prime field, additions and multiplications, a proof system loves, up to 70% cheaper to prove. It isn't a coin. It's the building block under the next idea. Because once your hash is proof-friendly, you can flip proof of work on its head. Nockchain, live since 2025, does exactly that. Miners don't hash random garbage, they run a fixed computation inside the Nock zero-knowledge virtual machine, generate a proof they did it correctly, and the hash of that proof becomes the block's nonce. Read that again. The work is producing a verifiable proof of computation. Same lottery, same security, but the effort is, in principle, real checkable work instead of pure heat. Let's line them up and watch one axis run through all of them. SHA-256, hash raw bytes, runs on ASICs, dead simple, bulletproof. RandomX, run a random program, stays on CPU's anti-ASIC. kHeavyHash, a matrix heavy hash depots and DAG-fast. Poseidon tool, algebra over a field built to be proven. Nockchain zkPoW, prove a computation, hash the proof, work for proof farms. See the progression from hashing bytes to hashing deliberately hard work to proving the work itself. And notice the hash quietly decides who mines. A warehouse of ASICs, the CPU in your laptop, a GPU rig, or a proof farm. So which hash wins? Wrong question. SHA-256 will likely secure the most value for a decade. Boring, proven, unkillable. But the energy is clearly flowing toward hashes that resist centralization, and increasingly, hashes that make the work mean something. RandomX kept mining human. kHeavyHash kept it fast. Poseidon 2 and zero-knowledge proof of work are quietly rewriting what work even is. That's the real story of proof of work in 2026, not which coin, but which math. I break down the next algorithms and the projects worth tracing in the free Discord, link below. This was Trace. I'll see you in the next one.